Hello, everybody, and welcome back to another Geography 340 climatology video. I am Zach Hilgendorf, and today we're going to be talking about Köppen climate regions. And the purpose of this video really is to serve as kind of a study aid to help you work through climographs and understand how to do that for your tests and quizzes. Although I have to say it is Saturday when I'm recording this. You see I'm a bit more casual and in less plaid than you've seen me in before. That's because it is opening college football day. Go Bucky, hoping for a win today, but I just had to throw that out there for any non-Wisconsin or Wisconsin fans. So let's start off by a quick review. This is Vladimir Köppen, a Russian and German scientist who devised the Köppen climate classification system. It's most widely used for classifying the world's climates, divides the Earth's surface into climatic regions that generally coincide with the world patterns of vegetation and soil. For you recall, he was a botanist, among many other things. And the Köppen system recognizes 5 major climate types based off of annual and monthly averages of temperature and precipitation. A, B, C, D, E. Plain and simple. But in more recent versions, there is an H. We've mentioned this in the past. That's for highland. These are typically climates that are driven by their elevation in these high alpine regions. We're not going to really focus on them here, but that's to say they do exist. Think of the Himalayas, think of the peaks of the Rockies. They do exist. We're just not really going to focus on them here. And then I wanted to say that these boundaries are dynamic. So think of it, these are average monthly and annual values that we're comparing. So as every new month is completed and added, these boundaries can shift a little bit. As every new year, or as every year ends, that adds another metric to our annual values. So these aren't static. We look at them as kind of static just for the purposes of learning, but one place can change from year to year, and that's to say many of these places are changing with the current climate crisis. So let's start off with A climates. These are humid tropical climates. They're winterless climates with months having a mean temperature of 18 degrees Celsius or above. Here are our A, F, A, M, and AW, tropical wet, monsoonal, and tropical dry and wet, or savanna climates. These are some of the ones we're going to be looking at here. So let's start off with Belém, Brazil, Akyab, Myanmar, and Bamako, Mali. Go ahead and pause the video now and try to figure out which ones each of these are. These match up with your guesses. For Belém, every month has more than 60 millimeters of precipitation, despite a summer-dominated precipitation regime. The temperature is consistent across the entire year, and these trends are typical of a tropical wet climate. Did you say AM or monsoonal for Akyab? You note that the summer months were dominated by significant precipitation that fell off during the winter months. This is pretty typical of a tropical monsoon climate. How about Bamako? Did you note the consistent temperatures and lower summer punctuated precipitation? Well, this defined winter dry season and relationship between the driest and wettest months, so less than 1/10 between the driest and the wettest, is consistent of tropical savanna climates. Let's give you 3 more here. You're looking now at Monrovia, Liberia, Singapore, and Acapulco, Mexico. Go ahead and pause now and try to figure these ones out on your own. Figuring it out yet? Monrovia is punctuated by strong summer precipitation and consistent temperatures, standard of a tropical monsoon climate. Singapore has consistent precipitation all year and a consistent climate. Definitely falls into the tropical wet climate based off of all of these metrics, and a continuous high precipitation value. What about Acapulco? Did you pick up on how dry the winters were compared to the summers? Again, tropical savanna climate. Moving into sea climates. These are our mild mid-latitude climates. And they're climates where the average temperature of the coldest month is below 18 degrees Celsius, but above -3 degrees Celsius. Here we can see where some of them are, and the ones that we're going to be looking at on the map today. We have CSA and CSB, Mediterranean, CFA, CFB, CWA, CWB, humid subtropic, and CFC, CWC, and CSC, marine west coast. Next up on our climographs, we have Dallas, Texas, Los Angeles, California, and Guangzhou, China. Go ahead and hit that pause button and try to figure these ones out. What'd you come up with for Dallas? Note that the temperatures dip below 10 degrees Celsius, but stay above -3 degrees Celsius in the colder months. The warmest month is hotter than 22 degrees Celsius, and at least 4 months are over 10 degrees Celsius. And the precipitation trends don't meet the criteria for a CW or CS climate. Moving on to LA, Los Angeles, did you get a CSB climate? See how there are at least 3 times more precipitation in the wettest winter month, February, than in the driest summer month, July or August in this case. Also note that the driest summer month gets less than 40 millimeters of precipitation. Finally, did you see that no month gets above 22 degrees Celsius, and there are at least 4 months above 10 degrees Celsius? There we go. Next up, Guangzhou. The telltale sign here is that there are at least 10 times as much precipitation in a summer month, or the wettest summer month, than in the driest winter month. As for temperature, like Dallas, the warmest month is over 22 degrees Celsius, and at least 4 months are over 10 degrees Celsius. Here are a few more sea climates. Go ahead and pause the video while you reason out what Athens, Greece, Sitka, Alaska, and Greenwich, England fall under. How'd you do this round? Athens is a CSA climate, indicated by the fact that there are at least 3 times more precipitation in the wettest winter month, November or December in this case, than in the driest summer month, July. Also, because the warmest month is hotter than 22 degrees Celsius, at least 4 months are over 10 degrees Celsius. That puts us into our CSA. Up in Sitka, Alaska, we have a CFC climate. The temperatures are all above -3 degrees Celsius, and 1 to 3 months are above 10 degrees Celsius. Also, rainfall does not meet the criteria for a CW or CS climate. Last for our sea climates is a CFB climate across the pond in Greenwich, England. For those geo nerds amongst us, that is the origin of our lines of longitude, the prime meridian. It's where they start, so that's 0 longitude. For climate, we've got rainfall that does not meet the CW or CS climate criteria, and for temperature, no month gets above an average of 22 degrees Celsius, and there are at least 4 months over 10 degrees Celsius. All right, off to our D climates. These are mid-latitude climates with severe winters. Climates where average temperature of the coldest month is below -3 degrees Celsius and the warmest monthly mean exceeds 10 degrees Celsius. Here we can see the location of some of the ones we're going to be looking at. We're going to start off with Chicago, Illinois, and Shenyang, China. Go ahead and pause the video now and try to figure these ones out. We've already gone through most of the designators in the sea climate, so we're going to kind of skim through them here. For Chicago, did you get a DFA climate? Precipitation does not meet the DS or DW criteria, and temperatures peak above 22 degrees Celsius, and there's no temperature below -3 degrees Celsius, and at least 4 temperatures are over 10 degrees Celsius. In Shenyang, precipitation in the wettest summer month is 10 times greater than the driest winter month, while temperature varies similar to that seen in Chicago. The lows are lower and the highs are higher. Next up, Verkhoyansk, Russia, and Dawson in the Yukon in Canada. Don't forget to pause. Here's a new one. Did you get a DWD climate for Verkhoyansk? This means that the wettest summer month is at least 10 times wetter than the driest winter month. And the average temperature of the coldest month is -3 degrees Celsius or less. For Dawson up in the Yukon, we've got a DFC climate, meaning that the criteria for a DS or DW climate cannot be met, and 1 to 3 months are above 10 degrees Celsius. All right, Moving on to E climates. These are summerless climates where the average temperature of the warmest month is less than 10 degrees Celsius. We see them here. We have ET for tundra and EF for ice caps or snow regions. We can see we are way up north or way down south. Next stop for us is Upernavik in Greenland and Icemit in Greenland. Before you pause, note the differences in the axes on these examples. They are slightly shifted from the ones we've been looking at prior. Good luck. Did you get an ET, polar tundra climate for Upernavik? The average temperature of the warmest month is greater than 0 degrees Celsius, but less than 10 degrees Celsius. How about an EF or snow and ice cap climate for Icemit? The warmest climate or warmest weather month, is 0 degrees Celsius or below. Now let's notice how close these two are. So recall in one of my previous videos, we talked about the moderating effect of large bodies of water. Upernavik is situated right along the coast, while Icemit is much further inland. So we can really see the effect that short distances can have on the dominant climate in a region. Here we have Little America in Antarctica and Barrow, Alaska. Again, please note the difference in the axes between the two examples while you're working through things. Go ahead and pause now. All right, Little America is an EF climate while Barrow is an ET climate. We're almost there. We're heading from the most frigid parts of our world to some of the hottest and the driest with B climates. Climates where evapotranspiration exceeds precipitation, resulting in a moisture deficiency. Here we can see some of the ones that we're going to be looking at in this little section. Starting off with Cloncurry, Australia, and Lovelock, Nevada. These are the first group of B climographs we're going to be looking at. So don't forget to use your figure 1 from the Köppen handout and pay attention to the hemispheres. For Cloncurry, we are in the southern hemisphere, so obviously winter in the northern hemisphere is summertime in the southern hemisphere. So go ahead and pause now and work through these. Did you get a BSH climate for Cloncurry? Note the summer concentration in rain and average annual temperatures of 18 degrees Celsius or more. For Lovelock, they live in a BWK climate with a even distribution of rainfall and average annual temperatures under 18 degrees Celsius. Here are our last two climographs for Semey, Kazakhstan and Cairo, Egypt. Go ahead and pause the video now. I'm sure you got these with no problem. Semey is a BSK climate, while Cairo is in a BWH climate. I hope this video was helpful. Gave us an opportunity to kind of work through some of these climographs and see how to look at them, what to look for, and how to come up with your own assumption of what that climate is. Now it's time to explore on your own if you'd like. So I'm going to provide a link on the Canvas page and in the space description below the video here. If you're interested in diving further into the Köppen climate distribution across the globe, look no further. These links contain 2 different versions of the data and 3 different resolutions of the data. I think we've got 5 meter, 10 meter, and 30 meter resolutions of the Köppen climate classification across the globe in KML, so the Google Earth format, and in TIFFs, so if you were using a GIS of some type. So go ahead, and if you want to explore more, go ahead to that link and download any of those and open up Google Earth or open up ArcGIS or QGIS and look for yourself. So I hope this video was helpful. Really, I think served to explain some of these a bit more than we got into in the last video. If you have any questions, feel free to reach out, but I will see you in the next video. Have a great day. Thank you.